Please tell me the amount of time I have.
So you have 30 to 40 minutes, sir.
Okay. So let me begin my talk. And the title of my talk is Semiconductor Chips and Classroom, Transforming Technical Education in India. There are some photographs here. So let me start explaining using these photographs. So let me first take up the word semiconductor chips. What exactly does it mean? Because I think I have a mixed audience, I would like to present the talk in a way in which someone who is not aware of these ideas can understand. In fact, there is a nice quotation which I tell people, particularly those who want to develop good teaching skills. Communication skills are very important for good teaching. And how do you know whether a person has communication skills? Someone has said you can claim to have communication skills if you can explain your ideas to your grandmother. In other words, ability to explain ideas to non-specialists is a mark of good communication skill. So let me try to implement this idea here. So I will be telling the audience about what is happening in Odisha in the area of semiconductors and what is required for developing the manpower for the semiconductor activity that is happening, and how the education should be transformed for this purpose and also for other reasons for improving the outcomes. Okay, so let me start with chip. Now this is a photograph which many of you would have seen. What is this? This is a integrated circuit chip. So the chip is inside this. Over the chip there is a package, and what you see is the package. It has connections on the sides to connect to the outside world. This is an integrated circuit chip in a package. On the other hand, this is a discrete device chip in a package. What is the difference? In this case, thousands of devices are there in an area of about 4 millimeter by 4 millimeter. That is why it is called an integrated circuit. So thousands of devices connected together, they form a circuit, and if these devices are made on the same substrate, it is called an integrated circuit. So, and that particular integrated circuit on the substrate is called the chip. And then you put a package so that you can connect the chip to outside world. As compared to this, here you have a single device on a substrate and then put in a package with connections to the outside world. So this is a package device chip. Now let's look at the third picture here. What is this? So this is a module. Now what is a module? In various chips are put together and some of the parts are packaged, and then there is an overall package of this. So various devices and packages put together, it is called a module. So this is an example of integrated module. The semiconductor activity revolves around making these particular devices. Okay. Now let me come to classroom and technical education. So this is an introduction. I'm only introducing the ideas, then I will go into details. So we discussed a little bit about semiconductor chips. Let me discuss a little bit about classroom. I'm trying to explain the title. What you see here is diagram of, or rather photograph of a active collaborative learning classroom. Normally, all our classrooms, in fact, our auditorium in which you are all seated, There you have rows of chairs. Normally classrooms are made like that, normally. However, this classroom is different. Here you have round tables and there movable chairs around the round table. So 3 movable chairs around the table, each table. What is the advantage of this kind of an arrangement in a classroom? The 3 people here can turn to the teacher when the teacher is lecturing, and when teacher gives them an activity, they can rearrange themselves facing each other so that they can do a collaborative activity. And they can learn through a collaborative activity. That is why it is called an active collaborative learning classroom. Since we are talking about transformation of technical education, we have to transform our classroom sessions from purely lectures into collaborative learning activities. So let me explain this a little more using this diagram here. Bookend design of a class session. How should a class session be done? It should not be purely lectures. First, there is a summary, then you have a lecture, summary of the previous class, you have a lecture, then you have a recapitulation of the ideas that you have given in the lecture. After that, you can again continue with the lecture. After this part, you have to have an active learning activity, where the students perform an activity. And if they perform together, as like in this classroom, it is called collaborative learning activity. So they have to be given an activity. It can be solving a problem, answering a question, or discussing something together. During the lectures and this recap, they are doing passive learning. That is, they are listening to the teacher. So this is called passive learning. But here, they are themselves active in trying to solve a problem or thinking. This is then followed by another lecture session, and finally you have the summary. So this particular design of a class, 50 minutes or 1 hour class, is called bookend design. So now, in my remaining part of the talk, I am going to expand on these ideas. So let us now focus on Odisha. Odisha is concentrating on these aspects. So what are these? These are power devices. Okay. So Gujarat is concentrating on integrated circuit chips in silicon. Odisha, on the other hand, is concentrating on power devices. Power devices means those devices which handle large amounts of current and voltage. They are used in electric vehicles, then rail Students can be asked to discuss among themselves about some topic. They can be asked to present to each other on some topic. Okay, they can be asked to solve a problem together. In today's world, apart from interdisciplinary background, another important thing for success is collaboration. Collaboration among different people, because one person cannot know all subjects. So people who are experts in different areas have to work together to solve a practical problem. No practical problem is entirely single discipline. Okay. Yeah. So any practical problem you take, it will have some component of mechanical engineering, some component of electrical engineering, some component of metallurgy, something like that, or physics, chemistry, mathematics, and things like that. Therefore, people of different backgrounds have to collaborate, and it has been found inability to collaborate is an important reason for people not succeeding in the profession. They just don't know how to collaborate because throughout education, they have been writing exams all by themselves. They have been studying mostly by themselves and so on. So even though they develop expertise in the subject, they may not develop the expertise to collaborate. One important ability that is required in collaboration is communication. And communication to people of other background. This is an art. So if you want to develop this, naturally, this skill develops only by practice. It is not by lecturing. Think of cycling. You cannot learn cycling only by watching a video of somebody learning cycling or taking a lecture from someone. You actually have to ride the cycle. Only then you develop the skill. Only when I do, I learn. Right? So that is why it is nice if in our pedagogy, students are exposed to collaborative activities continuously. And that is kind of thing that is possible if you rearrange our classroom in this fashion. Round tables and movable chairs. Okay, and 3 to 4 students on each table, and you give them collaborative activities during the class. If every student is exposed to this kind of sessions, collaborative sessions, throughout their education, then automatically they will develop the ability to collaborate. Okay, so now let me come to this particular design of a class session in more detail. The research has shown that you cannot hold the attention of the audience on a single topic with a speaker is speaking continuously for more than 15 to 20 minutes. So no teacher should actually speak continuously for more than 15 minutes. That is the advice. That is based on research. If so, then how do I handle a 1 hour class or 15 minutes class? Now, this is the solution that is given for that. So a typical class, for improving the student engagement in the class, one must start with a couple of minutes of summary about the previous lecture or previous session. Then continuously one can speak for 10 to 15 minutes, teaching a particular concept. Then what you do is you recapitulate in a summary of what has been done for 10 to 15 minutes. After that, you can resume your lecture. Okay, so here what is being done is there is a break in monotony. Instead of continuously lecturing, you are inserting 3 to 4 minutes of recapitulation. Okay, now after you have done this, then follow with an activity for 10 to 15 minutes. Now this is the duration in which students who are sitting in classroom like this can turn to each other and do the activity that is given. It could be problem solving, it could be answering a question, it could be discussing on a topic. Okay, any of these things. These are called active learning activities. So give the activity, but let them do it for 10 to 15 minutes. This again breaks the monotony and activates the learner. Then again you can give your lecture. Okay, and finally to summarize the entire class in another 3-4 minutes. Now, this is the method suggested by research for any conducting any class. Okay. Now, let me go into further details of how a lecture can be imparted, because we are talking about transforming education. Okay, transforming technical education. Let me look at my my clock. How much? I have 5 more minutes. Can someone tell me whether I have? I am not able to hear.
Yes, sir. You can have. You can take 5 more minutes, sir.
Now let us come to the lecture. Okay. It is very important for a teacher to learn the pace at which he or she should speak, and where during the speech there will be pauses. So pace, pause, and then the teacher should also use a proper accent. Sometimes what happens is, because the accent of the speaker is not understandable by students, even though the teacher is knowledgeable, they do not follow. That is point number 1 about communication skill. So pace, pause, and your accent. The next important thing is covering of the material. If you have a difficult concept to impart, then you must teach that concept from multiple points of view. You should not give only one explanation of the concept. You should give at least 2 different explanations. Okay? Aurobindo has said that education is not about learning diverse subjects. Education is not about learning diverse subjects. It is about learning diverse ways to the same subject. It's a very, very important statement. Education is about learning diverse ways to the same subject, not about learning diverse subjects. So multiple ways in which we can understand something. If you want to develop creativity, what is creativity? It is the ability to think differently. Okay? It is the ability to see the same thing as everyone else, but think differently. So how will you be able to think differently? Only when you know different ways of thinking. So different ways of understanding the same concept. Practical example. Suppose a mathematics teacher is teaching a theorem. Usually, the teacher gives only one proof of the theorem, but there can be more than one ways of proving the theorem. For example, Pythagoras theorem or Baudhayana. Baudhayana in India has presented the same idea much earlier than Pythagoras. It has more than 100 proofs. There is in fact a book called 100 Proofs of Pythagoras Theorem. So a teacher can teach 2 or 3 ways of proving the theorem. Now teacher may say, look, if I follow this kind of an approach, how will I cover the syllabus? Because I have to cover many subjects, right? But Aurobindo says, no, you have to cover many ways of doing the same subject. So what one can do is, teacher can teach one method in the class and give students to come up with another method in the assignment. Okay, so that way one can involve the students in, you can explain the concept to the student in multiple ways. This is very, very, very important for developing thinking ability, creative ability in students, as well as for improving the understanding of a concept. Among the multiple ways in which the concept can be imparted, analogy is a powerful method. Okay? In fact, if you study the origin of ideas, major ideas which have changed the world, okay, also scientific discoveries and so on, what you find is they are basically from analogical thinking. For example, the atomic structure, which has a nucleus in the center, and revolving entities like electrons and protons. How did the scientists think of this arrangement for atom? The scientists have noted that the macro world, or the entire universe, the structure is a sun and planets surrounding around it. This kind of an arrangement, configuration. Okay. Now, the scientists thought, if the macro world, MACRO, macro, if the bigger world is arranged like this, why not micro world, the small dimension world, right? Also have something like that, a central entity and other things revolving around it. The important point is to know what will be the central entity and what will revolve around it. But by analogy, the scientists have discovered the atomic structure in analogous to the planetary structure of the universe. So a teacher should give appealing analogies for concepts, and they help students to understand the difficult concepts easily. In fact, artificial intelligence today is a very important tool for good teaching. Suppose I do not know of a good analogy for a difficult concept, a concept which the students might difficult to understand. You can actually put this information in AI, and you can ask the AI tool to give you an analogy for introducing a particular concept in a simple manner. And the AI will give you multiple analogies and ideas. So that is how one can use AI in education. So one can discuss these points in detail. One can go on, one can have a workshop for telling the teachers how they can make a difference. Okay, but because limitation of the time, I will in the next couple of minutes mention what kind of a workshop we should have for teachers to know how they can make a difference. Okay, so the workshop can cover the following points, and this will be the last part of my talk, just 2 minutes. So we must tell the teachers what are the indicators of student learning and factors that affect this learning. Then we can introduce the teachers to the concept of a teaching portfolio as an evidence of teaching effectiveness. The teacher should be taught how to set questions at different levels of thinking, how to take feedback from learners, and how to give feedback to the learner to improve teaching and learning, how to make classes interactive, and the book and lecture model. I just mentioned about this book and lecture, okay? And finally, merits of oral and written examinations. So usually we use written examinations a lot, but oral examinations or interviews, they are a great method to test the thinking ability of the students as well as their communication skill, oral communication skill. We do not use Viva or interviews as effectively. We should know how to do this effectively. So these are some of the topics that can be covered in workshop. If you want to transform education, okay, we should conduct such workshops for teachers. We should teach the teachers how to teach. With these ideas, I think I will close my talk. If there are any questions or any comments, I'll be happy to take.
Thank you very much, sir.
Yeah. Hello. Yes. Yes. Every device. Yes, yes. Power device. Every power device is fitted with AHC. Yeah. Surface mounted chip. See, there are different ways in which heatsink. One simple approach is to put an adhesive on a heatsink and then just put the chip and paste it on the heatsink. There are multiple ways. Yeah. Yes, yeah. So I will, you look at this particular, is my slide visible? Not visible? No. I'm saying, is my slide visible now? Acha, 1 minute. Oh, sorry, yeah. I will, now it will be visible. Is it visible now? So you can see this particular, here, at the end, 3D glass. Can you see this 3D glass? 3D glass. You can see how many layers are there. You can, it all depends. You can have multiple layers, 4 or 5 layers. So it is like this. Normally, you would, the best 3D arrangement is usually very close to a cube, right? So it all depends what is your area. What is your area? In the vertical direction, you can go equal to the length direction of the area, right? Then it will be a cube. So you can have a cubic structure that can be, that can give you guidance of how many layers you can put. What layers? Sorry, that word I am not able to hear you clearly. Gate has been designed. Oh, gap. No. See, that's a good question. So there will not be any air gap. It will be all filled up. It will be filled up with something, some material. No gap will be, some insulating material will be put. No. That is what? That's the point. So heat will be eliminated from the sides and the surface. Yes, very much. Yes. Very happy to know. Yeah.
Thank you very much, sir, for your highly insightful and inspiring presentation on CHIPS and Classroom, transforming technical education in Odisha. Sir, your talk has beautifully connected the future of semiconductor technology with the transformation of technical education. You highlighted the importance of chip design, chip manufacturing, power devices, and semiconductor-based innovation, and how these areas can create new opportunities for Odisha to emerge as a strong semiconductor hub in the near future. At the same time, your discussion on transforming classroom teaching was very meaningful. Your emphasis on active collaborative learning, short lecture segments, recap, learning activities, the idea of teaching more by lecturing less is very relevant to NEP 2020, which focus on student-centric, skill-based, multidisciplinary, and outcome-based education. Your session has given us a clear message that the future of technical education depends not only on advanced technologies like semiconductors and power devices, but also on how we transform our classrooms into active learning spaces. Once again, on behalf of BPUT Odisha, I sincerely thank you, sir, for your valuable time, guidance, and inspiring session.
Thank you.
Thank you, sir. Next session.
Okay, so I'm logging off.
Yes, sir, thank you so much. So we shall now proceed with the felicitation of our distinguished dignitaries present on the dais. I humbly request our Honorable Vice Chancellor, Professor Amiya Kumar, sir, Biju Patnaik University of Technology, Odisha, to kindly come onto the stage and grace the dais. I request our Honorable Vice Chancellor, Sir, Professor Amiya Kumar, sir, to kindly felicitate Professor Akhil Ranjan Garg, Honorable Vice Chancellor, Bikaner Technical University, Bikaner, Rajasthan, with a token of appreciation. Thank you, sir. I also request our Honorable Vice Chancellor, sir, to kindly felicitate Deepankar Das, sir, SSUN, with a token of appreciation. Thank you, sir. We shall now move to the second talk of this morning session. After a very enriching discussion on semiconductor chip manufacturing. So we are privileged to have with us Professor Akhil Ranjan Garg, Honorable Vice Chancellor, Bikaner Technical